Welcome, math people. We are doing quadratic equations today. How do you solve quadratic equations? There are actually about 5 different ways that you can solve quadratic equations, but sometimes you're doing too much. There are simpler ways to solve quadratic equations based on the format of the equation itself. I'm hoping you can learn some tips and tricks today as we do a few examples. A quadratic equation is an equation where you have a polynomial whose highest power is 2, the degree is 2. Standard form of a quadratic equation is y equals ax squared plus bx plus c. Now, the quadratic does not have to be written in this order in order for A to be defined, B to be defined, or C to be defined. It could be bx plus ax squared plus c. It's not written in standard form, but remember that the a always goes with the x squared term. It's the leading term, that's the leading coefficient. B goes with the linear term, and c is the intercept where it does not have a variable with it. One more time, c is not attached to a variable, b is with the linear term, and a is the leading coefficient. Depending on the way that your quadratic looks, you want to look at it first, you can determine which method you're going to use to solve it. The quadratic formula works every single time. Is it the best method? No. Graphing works every single time. Is it the best method? No. It's very hard to get an accurate answer for graphing unless you have lattice points or integer points that has an x that's an integer and the y that's an integer. If you're dealing with something that's a square root of some number, you're not going to be able to get accurate with the graph unless you're using Desmos. My favorite way to solve quadratic equations is factoring and using the zero product property. Doesn't always work. If you can't factor it, you can't apply this method. In order to factor, you need to have something that factors. That seems kind of silly, but essentially you're looking for a quadratic that factors into integers. The things to consider, your equation needs to be equal to 0 first. The reason that it must equal 0 is because we want to use the zero product property. So what you do is you factor and then you set both of your pieces equal to 0 and solve. When you're factoring, you're going to have an x squared term and an x term. If you only have an x squared term, you don't want to factor. You want to use the principle of square roots. If you only have an x term, then you're not dealing with a quadratic that's linear. I recommend you factor the GCF first, and then you factor the remaining binomial or trinomial. Then once you do that, you set each of those factors equal to 0 and solve. Your result is then the solutions to the quadratic. The quadratic with the power of 2 has at most 2 solutions, 2 real solutions. Principles of square roots. The things to consider is that you need to have only an x squared term. You need to not have a linear term, meaning you don't have x squared plus x, just a x squared term. The idea behind the principles of square roots is that you get the x squared term by itself and then you square root both sides to solve. This could be that you have x plus a number inside the square. That's fine. It's just that you don't have x squared plus x or some version of that. So you isolate the squared term and then solve by square rooting. I think completing the square is awesome. Completing the square can be done almost all the time. If you have just an x squared term, you should be using the principle of square roots. If you can factor, you could complete the square as well, but you're doing more work than you need to. But completing the square involves a few steps. So things to consider is, are you doing it because you were told to? If so, then do it. I think it's fun. I'm a math teacher. I enjoy it. If you're not being told to complete the square, it's probably just as timely to use the quadratic formula. You need to have an x squared and an x term. If you have a leading coefficient, completing the square is more challenging. So I would definitely use the quadratic formula in that situation. It can be done, it just requires a little bit more math sense, which is fine. Then you need to determine what piece is added to both sides, and then you're going to factor, and then you're going to apply principles of square roots, and then you're going to solve. So it's involving the first two ideas that we've had to get this solution. Okay. The quadratic formula works every time, but again, if you can factor or use the principles of square root, it's more time consuming and not necessary. I believe you can sing the quadratic formula to Pop Goes the Weasel. You will not see that on this channel, but feel free to Google it. It's out there. The way that you follow the quadratic formula is that you take x equals opposite b plus or minus the square root of b squared minus 4ac, which what's underneath the square root is actually called the discriminant, times 2a. So again, you need to be able to identify your a, your b, and your c terms. If the discriminant is negative, that means you don't have any real answers, which means that your graph does not cross the x-axis. You could have a discriminant of 0, which means your graph has its maximum or minimum on the x-axis, or you could have positive roots, which means that your graph opens up or down, but starts either below the x-axis or above. It just means that you have positive answers. Your graph intersects twice. So remember, you have at most 2 real solutions. You either have 2 real solutions, 1 solution, or no real solutions. Graphing. Are you being asked to graph? If so, do it. If not, it works when you have integer solutions. Then you can clearly see, oh, great, it's going to hit here. But if your math is, if you're dealing with roots or your math is a little off, it's really hard to get an accurate answer on a graph if you're not dealing with integer solutions on graph paper. And to be honest, if you have integer solutions, you should have factored. So graphing, it does get you the answer, but I would say this is my least favorite option to getting you the answer. Let's see this in action. Let's look at a few of these different types of problems. I'm not going to graph any of them. Feel free to graph them. I'm just going to use the first 4 options. Okay, so I'm going to assess this. I have x squared minus 49, which means I have only an x squared term. I don't have an x term. I shouldn't be completing the square. I don't need to use the quadratic formula. I could factor this. This is actually a sum and difference where I could factor it. But because it's just an x squared term, I can isolate that x squared term and use the inverse of squaring and just square root. What I'm going to do is I'm going to add 49 to both sides. And I get x squared equals 49. And now that I have the x squared term by itself, I can square root both sides of that equation. I'm going to get x equals 7 because the square root of 49 is 7. However, this is a quadratic. You can square a positive 7 and you can also square a negative 7. That means that whenever you have an equation, you're going to have both positives and negatives. Might be real solutions, might be not real solutions. But in this case, negative 7 squared is 49 and positive 7 squared is 49. If you had factored, you would actually see the two solutions. If you had x plus 7 and x minus 7 equal to 0, that means that x plus 7 equals 0, x minus 7 equals 0, and x is equal to negative 7 and positive 7. That's where the 2 roots come from. Moving on to the next equation. It's not equal to 0, and I have an n squared and an n term. So I have a linear and a quadratic term. I'm going to add 40 to both sides and look at this problem. I have 2n squared minus 18n plus 40 equals 0. And what stands out to me is that these are all even. I'm going to factor out the 2 first. That's going to leave me with n squared minus 9n plus 20 equals 0. And now I can factor without a leading coefficient. So I need to think about what multiplies to positive 20 and adds to -9. I like to use the diamond method. Some people use the table. I'm looking at what multiplies to 20 that adds to -9. My factors of 20 are 1 and 20, 2 and 10, 4 and 5. They both have to be positive or negative because the sign of the multiplication is positive. I'm either looking for two positives or two negatives. The 9 is negative, which means that I need to add two negatives. I need a negative times a negative to give me a positive and a negative plus a negative to give me negative. That means I'm looking for the sum. 1 and 20 is 21, 2 and 10 is 12, 4 and 5 is 9. I've hit the jackpot here. -4 and -5 are my factors. You can factor by grouping to then write it. There's all sorts of videos on factoring out there. I have a few on my channel if you want to check them out. But I'm going to go ahead and jump to the fact that this is n-4 and n-5 as my factors. And then I'm going to set each of these factors equal to 0. I'm even going to set 2 equal to 0, n-4 equal to 0, and n-5 equal to 0. 2 does not equal 0. I'm going to add 4 to both sides, and I get n equals 4, add 5 to both sides, and n equals 5. That means that 4 and 5 are my solutions. Moving on to my next equation of m plus 8 squared equals 72, I have a single m term. And while this looks linear, it has squared. So m is going to be squared, but I do not want to expand this. I can actually go ahead and use the principle of square roots and square root both sides of the equation. The square root of m plus 8 squared is m plus 8. The square root of 72 is plus or minus square root 72. Square root 72 has some perfect squares inside of it that I can actually take out. 72 is actually 36 times 2, and the square root of 36 is 6. That's going to simplify. That gives me plus or minus 6 root 2. I'm not going to turn that into a decimal. I always want exact answers. I don't want to approximate unless I'm told to. I'm going to subtract 8 from both sides. And I'm going to have that m equals -8 plus or minus 6 root 2. You could write plus or minus 6 root 2 minus 8. I like to put the root in the second component. Now let's complete the square. Why am I completing the square? Because if I look at this, it doesn't look like I can use the principle of square roots. And if I try and factor it, I don't think it's going to factor. When I'm completing the square, the whole idea is I'm looking at the b term. And I'm trying to make a perfect square trinomial. What I'm going to do is I'm going to add the 22 to both sides. And I'm going to have r squared minus 8r plus some value is going to give me 28 plus some value. I'm looking for that value that's going to make a perfect square on the left-hand side, the perfect square trinomial. How I do this is I take half of b. Half of -8 is -4. And then I square it. -4 times -4 is positive 16. That means this question mark is going to become positive 16. R squared minus 8r plus 16 equals 28 plus 16 is 42. Factor the left, and it has to factor as a perfect square, which means it's going to be something to the second power. It's a perfect square trinomial. And it's always going to factor to half of b, which was -4. R minus 4 squared is r squared minus 8r plus 16. That equals 42. And now, even though it's not equal to 0, I can still employ the square root like I just did previously. I'm going to square root both sides, and I get r minus 4 equals root 42. 42 is 7 times 6. Nothing perfect inside that. I can't simplify that. But I can add, first of all, the plus and minus symbol, and I'm going to add 4 to both sides. r equals 4 plus or minus square root 42. And that's as simplified as I can go. Lastly, 4x squared plus 7x minus 7. I don't want to complete the square because I have a leading coefficient. I don't have a GCF I can factor. I don't want to try and factor this. I'm going to go ahead and use the quadratic formula. I'm going to identify that A is 4, B is 7, and C is negative 7. I'm going to rewrite the formula. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A, and substitute in the values that I have. X equals negative 7 plus or minus the square root of 7 squared. I always put parentheses there because if you have a negative, you want that negative to be squared in your calculator if you're using one. Minus 4 times negative 7 all over 2 times 4. And here's why I just start to simplify. Start doing the math to get things down until I get it into its most simplified form. I don't like decimals, like I said. I want an exact answer. That means if there's not a perfect square in here, I want to leave it with a root. X equals negative 7 plus or minus the square root of 7 squared is 49 minus 4 times 4 is 16 times negative 7 all over 2 times 4 is 8. X equals negative 7 plus or minus 49 plus 16 times 7 is 112. And a negative times a negative makes it a positive, all over 8. X equals negative 7 plus or minus 49 plus 112 is 161, all over 8. 161, it's not a prime number, but when I'm running through the list of my divisibility rules, it's not even. It doesn't add to a number that's divisible by 3. 4 doesn't go into 61. It's not going to end in 5 and 0. So it's not divisible by 5. It's not divisible by 10. 8's not going to go into it. 9 doesn't go into it. 6 won't because 2 doesn't go into it. So right now, I don't really have any. Let's see, 7 goes in there twice, 13, 23. So 7 times 23, and 7's prime and 23's prime. So I can't do anything with 161. So my answer is X equals negative 7 plus or minus the square root of 161 over 8. And that's as simplified as I can go. Hope this video was helpful. Thanks for watching.